Hello there, fellow YouTubers. I am Mgamerz, as you all know, and I have been not releasing many videos recently, and I apologize for that. There's a really good reason. I have been doing quite a bit of research over the summer. Not exactly research, more like developing software. And I am here to show you the introduction to GibberTalk, which has currently been under wraps, but I might have hinted at it a couple of times. So, without further ado, I'm going to walk you through my research poster that I just had. So, let's begin. As you guys know, I am Mgamerz. My name is actually Michael Perez, and I work under Dr. Marion Sheepers of the Boise State Math Department at Boise State University. And I've been studying previously in the last year linear feedback shift registers, which is a type of random number generation, where if you put something in, a random number stream comes out, and eventually the whole thing becomes linear, and it comes back out to the original number, and we go into a series of periodicity. So if you guys don't know what cryptography is the application of encrypting and decrypting data so that as it travels across a medium, a third party that intercepts it cannot possibly decode it. And what I mean here is if you want to log into a website, and this is just an example, this is not actually how it works. Say you have your password as Boise State. In human language it's read like this, but to a computer it's read like this in binary. But you don't want to just send this across the internet, because if someone has like a rogue piece of hardware on the way the packet travels to the other end, they can just record it. So what you do is you encrypt it. So you take all of this and you turn it into this, and then you send it across the internet like this. So if someone reads it like this, well, they're not going to know what it means. And if they do know what it means, they probably have a great job in cryptography. But unfortunately, things like that currently don't exist, where people can just read it. So if it gets to the other end and it decrypts properly, it should pop out the exact same message, which in this case it does. And then it's like, well, you're authenticated. That's how it works. That's kind of basically how it works. So my project objectives were to develop a linear feedback shift register, or LFSR for short, based cryptography program that has included email capability, so you can send and encrypt an email. Now, my other task was to develop a mobile companion program as part of a cryptographics tool suite that you can use for like research or business applications. And also with linear feedback shift registers, which I'll get back to in a minute, I'm supposed to use RSA to secure the encryption keys and decryption keys so that third parties can't just, oh look, here's the LFSR encrypted message, here's the keys to unlock it, here you go. So before I get into explaining how that all works, I should tell you a little bit about the background. In October 2010, I was working for the Student Talent Expansion Program, and I began developing in a beginner programming language called GML, or Game Maker Language. GibberTalk's first iteration, which was my cryptography demo, which you might see if you look on my blog. I don't know if I ever posted images of it. I think I did. Actually, yeah, I do remember posting a lot of images. But it became a demo, and I learned a lot of how to like write the code and what steps, what loops I would use to decrypt and encrypt messages. It turned into a demo so that you could like have someone test and see how it works. And then I started learning Java in the next semester, and I ported most of that code to Java. It wasn't too hard because they're both object oriented, so it was pretty easy. Now I started porting it to Android once I got my Android phone, which has been really nice. So I should unlock it. And it's been a long time. Right before I ended STEP, there was a big research conference called the Undergraduate Research Conference for Boise State. And I showed off my cryptography demo, which I put a lot of polish into, because my Java version was not yet available. And you can see my Java version over here, as soon as I zoom it in for you guys. Alright, so over here on the right, you can see my Java version. And, well, the interface is pretty ugly. I plan to change it. And on the left side of that, you can see my Android version, which is currently work in development. Both of these are not done yet. I'm still in my developing and debugging part of my development cycle. and I expected to complete it in early August 2010 following normal procedure. Most of STEP, which was all of last 2 semesters, was planning and researching, where I figured out how the code would work. Because it's not like scientific research per se, because when I do like research it, it's like the code's either going to work or the code's not going to work. And there's not really any in between. It's not like, oh, it kind of works. Although I'm kind of getting it to work right now. So that's how I did. And then I started developing and debugging GibberTalk for Java about, it was like February of this year. And then there's if you're a developer, you know any developers, they know how agonizingly terrible and how much you want to kill yourself when you're doing the developing and debugging stage, because you take code, you develop it, and then you test it, and when problems happen, you get a bug or something, and it crashes, and you have to fix it. And then when you fix it, 12 more things break, and it's it's terribly long, and it's the most time-intensive piece of... I just hate it. And then after we get most of the bugs worked out, we release it to a couple of people, and they're like, here, stress test it. We want you to try and break my program, delete files, do things people wouldn't do, have no internet connection, blah, 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 blah. And then it should break. Hopefully it doesn't break, but if your program does break and die and have problems, you go back into your developing and debugging stage, and you, once again, go into the agonizing process to fix it, and then we go back into testing. And then once all those are ironed out, you release it. And, well, from there, it kind of sucks, because then you just go all over again. But that's software life, and I like developing software. It's pretty fun. Now, picture down here, I'll zoom it in one more level. This poster, by the way, is 3 feet tall by 4 feet wide, so this makes it look kind of small, but it's really huge. So right here we have my group generator, which I'll talk about in a minute, and I have my Android version, which can talk to my desktop version and vice versa. So if you're in the field, I can just be like, oh, hey, oops, oh, hey, I need to type you a message, and voila, there's your message. And these images are actually not mock-ups. I shall show you. I don't know how well you can see that, but this is actually the typing interface, and you can type a message on it. Sorry, my hands are in braces. I've been working too much. But another thing that we have here is we have our settings, which just goes around and like gets you support. It shows your group ID, which I'll talk about in a sec. It also gives you settings for your SMTP server, because the way GibberTalk normally works is it just automatically sends out of the program. Because on the desktop version, there's problems when you try to attach a file. Not everyone sets up their accounts to use POP or IMAP or SMTP settings. So GibberTalk uses 2 types of encryption. It uses linear feedback shift registers, which I'm only going to explain partially because I don't want to jeopardize my program entirely. And it also uses the industry standard RSA. Now, some of you guys might have learned or might have heard of RSA. You might be asking, well, why wouldn't you just use RSA for the entire encryption if it's just industry standard? The thing about that is RSA is actually computationally intensive, and for things that have limited battery life, such as phones and to a lesser extent laptops, you don't want to have to waste like 3% of your battery trying to send a message that's 1,000 characters long. So linear feedback shift registers mitigates this, because you can generate a pseudo-random long string of numbers pretty quickly with that, and then encrypt the entire message like that really quickly, compared to RSA, where if you did a 1,000 character message, you have to cut the message up and then encrypt a piece, encrypt a piece, encrypt a piece. It's not too much slower, but it's actually computationally more intensive. But these days it's starting to be mitigated by having dual-core processors. They're going to be coming out with a quad-core by the end of the year. It's going to beat my previous computer and a phone. I'm going to be sad panda because that was a good computer. And it was expensive. Anyways, linear feedback shift registers work by when you put a number into... Actually, I just have a better way of showing you. Let's just fire up Firefox. Wikipedia has a great article on how this works. Pretty much, let me just type this in over here. Whoop, don't want you to see that. Linear feedback shift registers. The way it works is that if you put a seed into a linear feedback shift register, which is like kind of like a lawnmower, because once you start it up, it just keeps going. Except that a linear feedback shift register starts repeating itself over a certain amount of time, which is a weakness of it. But I've implemented things to mitigate stuff like that. So if we look over here on the right, hopefully this plays in full thing. But as you can see, there's a stream of digits coming, and I believe they're moving to the right. Yeah, they're moving to the right, and it's going around in a periodic, I think that's a word, circle. And eventually it's going to come around, and it's going to come around. You can actually build these, because they're so simple, into like a circuit board. And on their own, they're pretty weak because there's known attacks against them. But I have implemented extra methods to mitigate any good attacks on them. Anyways, pretty much what it does is you put a number in, it goes to the next number. The next one is based off the previous one, because that's the new seed value. And then the next one's based off the previous one, and then you move up, and then blah blah blah. And eventually, there's a whole algorithm to it, and I would have to do a whole video. I think I actually showed you how to do it in a previous video, but that got like no views. So, that's how linear feedback shift registers work. And anyways, and then it uses, when you use a linear feedback shift register to send the message, linear feedback shift registers are symmetric. So, because the way it works is that you have the Vernam cipher, which pretty much means that if you have a completely random string of text and you compare a message to it, there'll be no way anyone's going to be able to decrypt it except for a great stroke of luck. There's no way to just generate total randomness, and it will never be decryptable. Fortunately, that makes it pretty much impossible to make any use of encryption decryption, because if you can't decrypt it, there's not really any point to encrypting it, unless you're Julian Assange or something. Anyways, let's see here. So I can't just send my keys right over the internet for them to generate the same length and then decrypt my message. So pretty much what I do is I take RSA and I encrypt 41 characters of the message instead of the entire message of, like, say 1,000, and then I send it across the internet. And that's pretty much how my encryption methods work. It also has something called group ID. I don't know if that's trademarked or anything. If it is, I'll have to change the name. I don't mean to infringe. All the legal stuff, blah blah blah. Anyways, what it does is it takes your public key file. I am not sure how I'm going to implement this entirely yet. I'm still working on that. But it takes a hash of that, which pretty much just says, take all the bytes out of this file, perform an algorithm on it, and give me a number outside. And then that's how you check, like, if a file's integrity is good, because if even one byte's wrong, the hash that comes out is totally different. And that's supposed to be like that. So you put that in, and you put that into the linear feedback shift register. So if someone's outside of your group trying to send you a message, and they have a different public key file than you, they're considered to be in a different group. And you won't be able to decrypt it, and neither will they be able to decrypt your messages. And decryption is just simple as dragging and dropping the gib file on top of the decrypt thing. The little decrypt tab. And on the phone, I'm thinking I'll just have it where you click the attachment and it'll decrypt it for you. But first you'll have to type in a password to decrypt your private key file, so that if your phone does get stolen, there's time to do a remote wipe of your phone and clear out your email account and stuff before somebody's like, oh, encrypted message, doop, oh, research data, sweet. Anyways, in the future, I plan to release this onto the Android market and just like the Java version. And they're going to see real-world use in business and enterprise and research where people need to talk privately with each other. Just as a normal person, like a normal YouTuber, like kind of like me, I guess, I wouldn't exactly need this, but some other people at my university have actually expressed some interest actually from the conference I just went to. So I hope it does help people. Anyways, there's one last fundamental problem which I've brought up time and time again, which I'm just about to start mitigating, is that on Android I can be typing a message like this, or I can be typing a message like this, or I can be typing a message like this, or like this. And most phones these days have accelerometers or gyroscopes, which can measure gravity, which direction directly down is. Both of them don't measure direct gravity, but they're able to tell what direction down always is. Now, if I put this into my random seed, because you want it to be as random as possible, because if they have a logical starting point, it knocks out 99.9% of all guesswork to crack encryption. So you want to just remove all logical steps, or logical entry points. So if I type like this, I can use that as a random seed value, or I can type like this and use that as a random seed value. And there's not really any logical starting point because most phones might report this differently. Now, that's the one problem. Android has a bunch of sensors. They have lux sensor, proximity sensor, accelerometer sensors. Some have gyroscopes. You have microphones, video, battery life, all that stuff. Now with a desktop computer, you maybe have battery life, microphone, webcam. Most of those are hard to access software unless you have very specific information about what it works with, such as drivers. So what I use currently is the clock. So say you're typing up a message, say this is my computer, not my phone, and I type up a message and I'm done typing it. So I'm going to start encrypting it once all the message is all complete, and in which case I hit send, and that's when encryption starts, right? So there's going to be almost no time difference between the timestamp on the email, which is impossible to encrypt. It would be like encrypting your post office letter and expecting it to get to where it's supposed to go. It's never going to get there because the post office has to be able to read it, and they'll have a log of when it was sent and stuff. So that gives them a great logical starting point if it's based on the clock for a seed value. You can just be like, 12:30 was sent, I'll start at 12:25 and go all the way up to 12:40 and try every possible value from there to 12:40, and eventually I'm going to find it. And that gives them a great logical starting point to start and try breaking encryption. So instead, I'm starting to think of doing hardware setup or geolocation, or if I could figure out how to do maybe like a webcam. None of it will be like to report, oh, you're located here. It'll be more like saying, oh, you're located here. We're going to base your current like GPS coordinates as a seed value. So unless they know exactly where you're sitting, that's going to be pretty hard to get a good seed value out of that. The group generator over here will eventually include a editor, so you can edit members in and edit members out. Every time you edit it, though, the group ID changes because it's based on the hash. So everyone has to be upgraded at the same time to still be considered in a group, but they'll have a different group ID. Otherwise, they'll break the group and you won't be able to talk to each other. Anyways, the suite we maintained for a couple of years. This is supposed to be about a 4-minute speech, but I dragged it out into about 20. I hope that at least enlightens you into why I haven't been producing that many videos recently. I've been pretty busy with this. And then I also have a girlfriend, and everyone knows how much time those people take up. Anyways, I suppose I have to acknowledge that the National Science Foundation has given me 2 awards for, or at least like funding under awards, from the National Science Foundation Science, Technology, Engineering, Mathematics Student Talent Expansion Program, STEP, under award number 0856815. An additional was provided from LSAMP, or the Louis Stokes Alliances for Minority Participation, under award number HRD-0901996. Any opinions, findings, and conclusions or recommendations expressed in this material are those of the authors and do not reflect the views of the National Science Foundation. And I have to thank Siphon187 for helping me debug some of my code right now. And he's going to be my alpha and one of my beta testers for my program. And he always tells me not to drink in the lab. But I like bacon and orange juice, I'm sorry. Anyways, in the future, if you want to like help me at all, I need someone who's good with like Illustrator or somewhat vector graphics, because I'm going to need a logo that needs to be able to scale. I might need someone who's good with videos, because I want to make a promotional video of it at least, because I'm pretty bad at video editing. I mean, I can do it, but it takes me so many hours to do it. It's like, and if you want to help me beta test, I'll put a link down here. You need Android 2.0 or higher, and you need a modern desktop computer that runs at least XP, or that's about it. It's 22 minutes in, and I shall bid you guys adieu. A Mountain Dew.